Law of radioactive decay. Introduction. Hello students. Today we are going to learn about an important nuclear physics concept called law of radioactive decay. In a radioactive sample, there are millions of unstable nuclei, but all nuclei do not decay at the same time. Radioactive decay is a random process, just like tossing a coin. We cannot predict each event, but we can predict probability. Let's learn about random nature of radioactive decay. Here we have a atomic nucleus whose atomic number is greater than 82. These undergo natural radioactivity that decay by emitting alpha, beta and gamma. Radioactive sample contain a large number of nuclei. All nuclei do not decay at the same time. Decay is a random process. We cannot predict which nucleus will decay, but we can predict how many will decay on average over time. Rate of radioactive decay. The rate of decay is proportional to the number of undecayed nuclei present. The rate of decay is proportional to the number of undecayed nuclei present. Minus dn upon dt proportional to n. Here, the n is the number of undecayed nuclei present. The dn by dt is the rate of decay. So, rate of decay is proportional to the number of undecayed nuclei present. The negative sign indicates that n decreases with time. Introducing a proportionality constant lambda, we get dn upon dt equals minus lambda n is a radioactive law. Expression for radioactive decay. Let's rewrite this equation. Dn upon dt equals minus lambda n. Let us rearrange few terms here to go for integration. So we get dn upon n equals minus lambda dt. Integrating on either side, we get integration n0 to n dn upon n equals minus integration 0 to t dt. On the left hand side, we get log n. Lower limit is n0, upper limit is n. The n0 is the initial number of atom. Integration 0 to t dt, simply t. Let's go further. So on substituting upper limit and lower limit, we get log n upon n0 equals minus lambda t. Taking exponent on either side, we get n upon n0 equals e power minus lambda t. So the equation is n equals n0 e power minus lambda t. This equation is called law of radioactive decay. It shows that radioactive decay follows an exponential decrease. So, this implies that the time taken for all radioactive nuclei to decay will be infinite. Let's see a graph. On x-axis we take time and on y-axis we take number of undecayed nuclei. At time 0, that's at initially, the total number of atoms are n0. Half of the time, the t half, after t half of the number decayed. Only half of the number is undecayed. The remaining another half-life period. So half of n0 upon 2 becomes undecayed. So every half-life period, 1 upon 2 amount has been decayed, 1 upon 2 amount has been retained undecayed. So it takes infinite time to completely decay. If you look at the x-axis, this x-axis never touch the graph. Activity, decay rate. Activity R, the number of nuclei decaying per second. Activity means number of nuclei decaying per second. Whether the nucleus is highly radioactive or very less radioactive, we can measure it with the help of a physical quantity called activity. That means number of nuclei decaying per second. So R is a positive number, a modulus of dN upon dt. We remember the law of radioactive decay, dN upon dt equals minus lambda n. So let us find R is simply lambda n. Here R naught is the initial activity, that will be lambda n naught. R is the activity at a time t and R naught is the initial activity. Since n decreases with time, the activity also decreases. Substituting the value R and R naught in the place first equation, we get R equals R naught times e power minus lambda t. So we have to remember the n equal to n naught e power minus lambda t and R equals R naught e power minus lambda t in solving problems. Units of activity. SI unit of activity is becquerel. 1 becquerel equals 1 decay per second. Remember, 1 becquerel means 1 decay per second. Let's learn another unit, curie. 1 curie is 3.7 multiplied 10 power 10 decay per second. So 1 curie equals 3.7 multiplied 10 power 10 becquerel. Remember, originally 1 curie means the activity of 1 gram of radium. So 1 curie is defined as the activity of 1 gram of radium. So remember students, radioactive decay is a random process, but it follows the exponential law. N equals N naught e power minus lambda t or R equals R naught e power minus lambda t.